So today we're starting our notes over parallel and perpendicular lines. We're getting into a smidgen of geometry, just a smidge, okay? Who can tell me a generalized definition, aka general definition of parallel lines? To get like that.
To be equal.
To be equal.
Lines that never touch.
Never touch.
Lines that never touch.
Oh, that's so true.
Lines that never touch. Good job, Brett. I heard you. Now, I'm not going to put touch. I'm going to put intersect. I'm going to use the more scientific term there. Lines that never intersect. Now, algebraically, aka numerically, okay, how do we know if two lines are parallel? You're not supposed to know that. This is the new part, okay? The way we know this is if they have and in all caps and underlined twice and an exclamation point, they have the same slope. That's how you know when equations are parallel. Okay? Not just if a graph, but if you have equations. Like, for example, y equals 2x plus 7, and then you're given another equation, y equals 2x minus 1. Are the slopes the same?
No. Yes. Yeah.
Yes. Okay. Are the y-intercepts the same?
No.
Do we even care?
No.
No, we don't even care. We only look at the slopes. That's the most important detail. If I want parallel lines, the slopes must be the same. Okay. Who can give me a broad general definition of perpendicular lines? Crossover, intersect, but there's a specific attribute of them. There's a specific attribute.
They all go the same. What? They make a cross.
Okay, they make a cross. Now, a cross makes what type of angle?
A right angle.
A right angle, 90 degrees. Okay, so not only are they lines that intersect or cross, but they must create a right angle. Okay, so they are lines that, and I'll just use cross just because of spacing, cross that create a right angle. Not angel, angle. You spelled cross wrong? She put cruce. So, algebraically, because we are in algebra, how do we know if two lines are perpendicular? Can they have the same slope? No, because that's what type of lines? Parallel lines. Okay? Perpendicular lines have, in all caps, opposite, underline, reciprocal, all caps, slopes. Exclamation point. So this is not the first time we've heard the word reciprocal. Okay. In this aspect, opposite, we are talking about positive and negative numbers, not plus or minus, positive or negative numbers. Reciprocal, nope, that is not reciprocal. Okay, that is, now reciprocal is a part of keep, change, flip. Which part of it is? It's the flip. Reciprocal is a flip. Reciprocal is a fraction flipped. So reciprocal isn't keep change flip, it's a part of keep change flip. It is the flip in keep change flip. Okay? It's the flip. Now, an example of slopes would be if I had y equals 2x minus 7. The opposite reciprocal slope would be y equals, what's the opposite sign of positive? Negative. What is the reciprocal of 2? Again, fraction flipped. Is 2 in a fraction? 1 over 2. We did flip the numbers. The slope. We only flip the slope. Do we care about the y-intercept? No. This could be minus infinity. I don't care. It's about the slopes. And the slopes are what's attached to the x value. Right? Because y equals mx plus b. M is your slope. Now, why is the reciprocal of 2 1/2? Because if I put 2 as a fraction, I would have to put it over 1 to make it a fraction, because it's a whole number. And so you flip it, where 1 now becomes 2, where 2 is, and 2 goes to where 1 is. I made it up, because it doesn't matter. Why is it there? Because you got to understand that you're going to have equations that will have it. Literally every example we have has a b. But do we care about the b?
Yes.
No.
Wait, sometimes
You only care about the b is if you're trying to graph the linear equation. But I'm not trying to graph it, right? No, I'm just trying to see if they're parallel, perpendicular, or not. Now, negative reciprocals, that's just when your reciprocal becomes a negative. So if 3/4 is my original, negative reciprocal, aka perpendicular slope, would be negative 4 over 3. My perpendicular line with a slope of 2, or a negative reciprocal, opposite reciprocal, would be negative 1 over 2. What would be the opposite reciprocal, or, aka negative reciprocal, synonyms, okay, of negative 7 over 8? Positive 8 over 7. What is the opposite reciprocal of 1? Boom, negative 1. Because if I put 1 over 1, isn't it just 1?
Yes.
Say 1 more time. I said 1 more time. 1. Say it one more time. If I have a slope of 0, what type of line do I have?
Undefined.
Wow, no. If I have a slope of 0, what type of line do I have? Hoi. Horizontal. What is the opposite of a horizontal line? A vertical line, which has what type of slope? Ah. Yeah, you weren't answering my actual question. So, at the end of the day, you said undefined. However, you did not answer the question I was actually asking. You were just shouting out words. Okay? So, again, 0 slope, horizontal line. The opposite of horizontal is vertical. Vertical lines have an undefined slope. Yes, that is in your homework today. Just be aware. Okay? All right. In questions 9 through 16, we need to identify if the slopes are parallel, perpendicular, or neither. Okay? Now, we can abbreviate. That's our abbreviation for a parallel. That's our abbreviation for perpendicular. Niet. Niet.
Yeah.
Neither. Niet. No. However, the correct way to spell neither is in like that. I changed my mind. We're not going to do niet. Nah, we're not going to do Russian. You know what? That is too long. Let's do this.
None. Let's put yet.
No, we're not going to go with the Russian.
Why? It's fine.
We'll verbalize it, but we won't write it. All right. First and foremost, what type of form are these equations in? Slope-intercept. The only way to figure out slope based on the last page of notes we did over here, based on the last page of notes, the only way to identify slope is if we're in slope-intercept form. Huh. Maybe that's why we did key attributes the last time. Interesting. Interesting. Okay, so here we go. In y equals mx plus b, is 7 or 2 my slope? 7. Don't even care about that. Okay? In my second equation, is 7 the slope or negative 1?
7.
Don't even care about that. Now, looking at these two slopes, are they the same? They are the same, so I have parallel lines. Para. Same wavelength. Para. All right, numero 10. Are these in slope-intercept form?
Yes.
Yes. Okay, first and foremost, I, Coach Kimball, like to scratch out the y-intercepts because when I'm identifying parallel and perpendicular, what is the only thing I care about? The slope. Okay, now let's look at this slope. I have positive 4 over 5. The other slope, I have what? Negative 5 over 4. So I have to ask two questions here. First question, or actually 3 questions, technically 3. First question is, are they the same?
No.
Parallel is out the window. Okay, they're not the same. Okay, now the next 2 questions will identify if it's perpendicular or not. Question number 1, are they opposites? AKA, is one positive and one negative?
Yes.
Yes, so that fits the first criteria. Second criteria is the second slope given to me the first slope flipped? AKA a reciprocal? Yes. If I answer yes to both those questions, it's a perp. She's very prepped for class. Ouch. 11. Again, I don't care about y-intercepts. All I care about is the slope. Question number 1. Are they the exact same?
No.
No. Is one positive and one negative? Yes. Is the second slope a reciprocal of the first one? No. So I did not fit the perpendicular criteria, so this is neither. Or niet. Or none. Niet. Nunca. 9. Tim knew what I was talking about. What? What? What does 9 mean? See? You do know what I'm talking about. German. It's actually not. It's actually not. 9.
Put the number over 1, right?
To flip it. If it's a whole number, yeah. All right. Now, 12 looks oddly different from 9, 10, and 11. It's not in slope-intercept form. Isa. Thank you. All right, it's not in slope-intercept form. So what do? We make it into y-intercept form. Slope-intercept form. I don't know why I said y-intercept. Slope-intercept form. So just like in the warm-up question number 3 today, I will subtract my x to both sides. And then I will isolate my y to where I have y equals negative 1/6 x plus 5. What about my second equation? Is it in slope-intercept form?
No. You divide by 3.
Yes and no. It's almost. What's the one final step I need to do? Divide by 3. So now I have my two slopes, negative 1/6 and 6. Question number 1, are they the same? No. Okay. Question number 2, if the first answer is no, question number 2 is, are they opposites?
Yes.
Yes. One is negative and one is positive. Question number 3, is the second slope, 6, a reciprocal of 1/6?
Yes.
Yes, it is. So that tells me we have a perp in our midst. I want y'all to do number 13 and number 15. 13 and 15, and then we'll spin the wheel of not ideal. Aww.
And when the y is negative, you add 1 to everything. Would you divide by 1? Negative 1. Okay.
I knew you'd get to it eventually. On question 13, you have to solve at least one of the equation because one of them is in standard form, one is in your slope-intercept form. So, like, this is your standard form, so you need to convert it to y equals mx plus b. This one's already in y equals mx plus b, so you don't need to do anything. You only need to convert one of the equations. And then 15, they're actually both in slope-intercept, so...
In the negative 4y, you would subtract by negative 4.
right, let's see. Who's not here today? You're not here, and you're not here. All right, time for everyone's moment. Time for the wheel of not ideal. Spin. Jose, please do number 13. Where's your work? That's why it's the wheel of not ideal, because you actually have to show some work. Maybe you should bring your paper up with you, because it's not a quiz. You can have your paper with you. So how do you know it's perpendicular if you did no work? You want me to help you out, Jose? All right, erase perpendicular real quick. All right, so the most important thing is to get this to slope-intercept form. So the first thing I do is I need to subtract 5x to both sides to where now I have negative y equals negative 5x plus 4. I want a positive y, so I got to basically divide by negative 1 to both sides because that's technically negative 1. To where now I have y equals positive 5x minus 4. Now I have this slope and I have this slope. Are they the same? No. Are they opposites? Yes. Is one the reciprocal of the other? Yes. That is how we get perpendicular. Okay, so you had to do what we did on the warm-up, third question of the warm-up, convert to slope-intercept form. All right? Time for the wheel of not ideal for number 15. Connor! Aw. It's a good thing you don't need to solve anything. You just need to look at it. What'd you get? Why is it perp? Because they're different. What is this slope? That one's positive 1. This one's negative 1. And if I put each one over 1, doesn't matter. They'd still be 1 because 1 is 1. Say 1 again. 1. Okay? So that's why they are perpendicular. All right. Sweet. Awesome. Wonderful. Great. Grand. Can you go up there and erase perp? Yes. Thank you. Now, I want to talk about number 16 because 16 is a special case. Special case here. I have a variable opposite of a constant with the equal sign in between. Okay? So a variable opposite of a constant. Now, what that tells me is I am in the world of Hoy and Vux. Okay? I am in the world of Hoy and Vux. All right? Now, y equals 6. What is the slope of a horizontal line? 0. And what is the opposite of 0?
Undefined.
Undefined. So in order for this second equation to be considered opposite is I need two opposite variables. So if y equals 6 is my first, my second equation must be x equals for them to be opposites. I can't have y equals 6 and then this one also be y equals negative 1. Because what would they actually be? Y'all are saying every single word but the one word you need to say. Parallel. They would be parallel, okay? Because they would have the same slope, right? They're both y equals a constant. They're both Hoy's, so they both have a 0 slope. I'm looking at you, Issa. Yes? They are both y equals a constant, so they both be Hoy's. So in order for them to be opposites, okay, one needs to be y equals, the other one needs to be x equals. If they're both x equals, they are what? Parallel. If they're both y equals, they're what? If they're both y equals, what are they? Parallel. If they're both x equals, what are they? Still parallel, right? If one is x equals and one is y equals, what are they? Perpendicular. No. All right. Writing equations given parallel and perpendicular definitions. What are we doing exactly? Given a linear equation and a certain point, you can create another equation that passes through the point that it gives you and either parallel or perpendicular line from the given. Now, keep in mind the following points. Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal. Opposite reciprocal slope. Okay? So, parallel example here. Write the equation of the line that passes through the point -2, 7. I have told you since day one, if you have a problem and it gives you a point, what do we do to the point? X, Y, Y1. All right. X, Y, Y1. X1, Y1. X1, Y1. No matter what. We don't even know what the equation actually is asking. We just know that I have an ordered pair and I need to label it. Okay? Next thing it says, I'm creating an equation that is parallel to this equation. Parallel. Parallel means what? The same slope. Okay? So what is the slope of this equation? -4, not the x, just the number itself. Okay? -4. Hey, question. What was the first thing y'all learned in this unit? It's a new form. Right. I don't need y'all to tell me the whole equation. What is the name of it? Point slope. We learned point slope, which is the equation y'all were giving me. The reason why I wanted the name of it is because, do you have a point? Do I have a slope? Could I use point slope to create a new line? Yes! So, we have y minus y1 equals m times x minus x1. Okay? I have a point. I have a slope. I have point slope. Okay? So, I'm going to substitute, because Algebra 1 is what? Substituting and simplifying. That's all Algebra 1 is. The only difference is what equation I give you. That's it. So I'm going to substitute. Y minus 7 equals, our m is -4, x minus -2. Uh-oh, foggy. This is foggy. Why is it foggy? Because I have a minus and negative. Think about mathematically, multiplication. Negative times a negative is a positive. So let's make a negative and a negative a positive. Unfoggy, now we simplify. To simplify point slope to slope intercept, it's 2 steps. That's it. 2. Step 1 starts with the letter D and it rhymes with distribute. Distribute. So now I have y minus 7 equals -4x minus 8. Minus 8. Step 2. is what?
Plus
Move the
7.
7.
Yes. Move the 7
Plus 7.
by plus 7. Plus 7? Plus 7ing. To where now I have y equals negative 4x minus 1. Do I have an equation in y equals mx plus b format?
Yes.
Yes. Do I have the same slopes?
Yes.
Yeah.
Yes, and I should because it said to have the same slopes, right? Do I have the same y-intercepts?
Yes. No. Yes. No. No. You don't.
No. Here's another question, a really more important question. Do I care about the y-intercepts? No. So was my question pointless? Yes. Trying to keep you on your toes. Let's go to example number 3. Does anyone need that still up there, or can I go ahead and scroll up? Scroll. Sounded like you said scraw. Just scraw. All right. Write the equation of the line that passes through a point. What do I do with ordered pairs? Label them. And is perpendicular. Perpendicular means I need to have a opposite reciprocal. Oprecip. Oprecip. All right. So if the current slope I am given is 2, first question I'm going to ask you is, what's the opposite of 2? Negative. Okay. What is the reciprocal of 2? 1 over 2. I now have a point. I have a slope. So I have point slope. Point intercept is definitely not anything. Good thing you didn't say it. Okay? Now, algebra boils down to 2 main concepts. Concept number 1 is Coach Kimball's favorite mathematical principle of all time. Substitution. So let's substitute. We have y minus 3 equals negative 1/2 times x minus 4. Coach Kimball's second favorite mathematical principle, because it's the second thing you do in Algebra 1. No. Simplify. Simplifying. Okay? But in order to simplify, what do we do? Okay? So I have y minus 3 equals negative 1/2 x. Negative times a negative is a positive. What's half of 4? 2. Okay? Then from here, I need to do my second and final step and move my y1 term, which in this case is negative 3. How do I move that? Plus 3. Good, Connor. I'm going to write my answer right here. Y equals negative 1/2 x plus 5. Okay? Quick question. Are my slopes opposites? Yes. Are they reciprocals of each other? Yes. Are my b values the same? No. Do I even care? No, I don't even care. Does Coach Kimball keep asking y'all just to be annoying? Yes. Turn the page. Last page. All right. You are going to solve 5 and 8. I want you, we did 2 examples. We did one parallel example and one perpendicular example. Okay, right now we are doing nothing but parallel. 5 and 8 wants parallel. So 5 and 8 are looking for same slopes. 5 and 8 are parallel. I'll say it one more time. 5 and 8 are parallel. So I want you to create a new equation that will go through the point that's provided. and that the lines are parallel to the current equation that is up there. So I'll let y'all do that. Then we will spin the wheel of not ideal. Because no one likes to go up to the board and give their examples.
I mean, if you just say raise your hand, I'm pretty sure.
Yeah, but then I end up calling on the same people over and over.
Which is us, so you should not, like, when the wheels put on us,
Which is us.
you should not let it go up there.
I should not let y'all go up there?
Yeah, let's somebody open the one.
What'd you get on this? It feels like you did the wrong equation. What was the answer?
Wait, why are y'all doing opposites?
Wait, never mind.
Girl, you
Never mind.
5 and 8 are parallel.
Oh.
5 and 8 are both looking for parallel. 5 and 8 are looking for parallel, not perpendicular. For number 5.
Oh, dang.
No.
Me then.
Oh.
That's good.
Jordan! Connor literally just went, so it's...
That made my heart go.
Connor literally just went. It's a high possibility.
I don't think I could show up.
I have faith that you didn't.
I might be the only person who wants to go. It's never done.
And see, you're testing the fates. That's the problem.
You're saying if you want to go.
He's saying that he wants to go up and give his answer, but the Wheel of Not Ideal takes that into account.
It isn't for you.
That's why it's called the Wheel of Not Ideal. It usually calls on the people that don't want to go up.
Oh, I want to go on the wheel.
I want to go up wheel. Y equals 2x plus 7 is correct. Yay! Number 8. Kinsey! I bet Kinsey was over there. Please don't pick me. Please don't pick me. Please don't pick me. Oh, wait, let me scoot this up for you. There you go.
When Coach Campbell, when there's a like it's like you do it by 8, right? I feel like that's a 1. Y, right? Because Y is equal 1. Equal to 1. Or am I totally just wrong?
Where are you getting 8 from?
Where am I going?
Y equals negative 5 over 2x minus 8 is correct. Wait, hold up. Yes, it is.
Yeah, it is.
Yeah, it is. Sorry. Yes, it is. Where are you getting your 8 from? I don't either. I have no idea where you're getting your 8 from. That is great, Kinsey. Yep, I'll go ahead and erase it. Perfect. Thank you. No. I was taught how to write by my sister, kind of, and so that's why my handwriting is so bubbly. This is the best way to put it. The 2 ones I want you to do on this one is 9 and 11. 9 and 11. 9, 11. 911.
The perpendicular one is like just the same one, right? The
What?
same way of doing it.
What?
It's the same way of doing it on the perpendicular.
Same way as the top 2, except we're doing perpendicular, so you need opposite reciprocal. Hey, 9 and 11 is looking for perpendicular lines this time, Kimura, so now you actually can do your oppositeness. So your slope needs to be its opposite reciprocal, so the fraction flipped.
Yeah, that's what I was thinking.
Yes, 9/11. I was in my 6th grade history class. My history, my middle school, like my class had tile flooring up on the second floor and first. I was on the second floor going to my history class. As I walked in, my history teacher, who had a TV in like the corner of like where I have the shelving, she had like all classes had a TV. So the TV, she had it on the news, and that's when we saw it right then and there. And so I was in my 6th grade history class. What did I think of it? Devastating. At the time, I had an uncle who lived in New York, so I was worried about that. But he ended up being totally fine. Remember, we got opposite reciprocal slopes. So make sure you take the slope you're given, making it opposite, so a positive becomes a negative, and then flip your fraction. Everything's the same. You still use point slope. The only difference is you change your slope. You still use the point slope formula, though.
Do we have advisory today?
No. So we get out of here at 40.
How do you make the fraction on this again?
Alpha. X.
Let's set it up like this.
No. Where's this 5 coming from? That's not your slope, though. What's the slope in this equation?
3/4.
3/4, right? So we're doing perpendicular lines. So that means opposite reciprocal. All that means is I go from a positive to a negative, okay, and I flip my fraction. You just flip the fraction. So if I have a positive 3/4, what's the opposite?
4/3. Negative 4/3.
Negative 4/3. So where you have the 5 should be the negative 4/3.
Then what do I put the 5?
5 goes nowhere. It's the b. We don't care about the b. Do not care about the b. And then in your parentheses, your y minus your y1, what's the value of your y1? Positive 3 or negative 3? Negative 3. So when I substitute, that's foggy, so I got to make it a positive. So it should be y plus 3 equals
Oh, I forgot about that.
negative 4/3 times x minus 3. Time to spin the wheel of not ideal?
No.
Oh. I was so ready. Time to spin the wheel of not ideal! Nope, kids already went.
No.
Xavier! Number 9, and number 9 only, please. Number 9. Número 9. Wah, 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 wah. Xavier. Perpendicular. Not parallel. There you go.